Hello everybody, have a good day. I am Murshitha Shajahan from E&I department of B.S. Abdurrahman Crescent University. Today I am going to take class about temperature measurement. This is the overall overview of the class. Today's class contains the following. It is the need of temperature measurements, why we are going to do that temperature measurement, and what are the sensors commonly used for the temperature measurement. So, in that sensor there are so many sensors, thermocouple, resistive temperature sensors. Then we are going to study the comparison study. After that we will have the summary and question and answer sessions. Okay. First, what is the need of temperature measurement? So, why the temperature should be measured and monitored? So, the temperature is one of the very critical and important process parameters to be measured and or to be monitored in various industries, process industries, manufacturing industries, etc. So, this temperature range from the simple, it may be vary from simple monitoring of the water temperature of an engine, and it is a complex temperature measurement of a laser welding operations like that, etc. So, more difficult measurements such as the temperature of the smoke gas from the power generating station, blast furnace, exhaust gas, or in the rocket. So, it is also a kind of where the temperature measurements needs to be. So, the temperature measurements, how can we measure the temperature? So, how we have to use something to measure the temperature. For example, in the normal day to day life, if I feel something hot, so if I touch something on some hot surface, I can feel the temperature. So, because my skin is act as a sensor. So, the same way we have to measure the temperature by means of a array of sensors. So, all of the sensors infer temperature by sensing some change in the physical characteristics. So, that is the common and base principle of the temperature measurement. So, what are the commonly used temperature sensors available means? So, normally they will go with industrial people, they will go with thermocouples, RTDs and pyrometers. The first two will have a contact type of temperature measurement, and the last one, pyrometer, is a non-contact type of temperature measurement. So, this is the thermocouple. So, the figure shows the thermocouple. This is the physical thermocouple, right. So, it is contained a sensor portion, this is the sensor portion, okay. It's actual thermocouple. The thermocouple, how it works? So, it converts the thermal potential difference into electrical difference. So, what is the thermal potential difference? It is a heat energy. So, it converts the heat energy in the form of a electrical potential difference. So, the basic principle of this thermocouple is, it is called as a thermoelectric effect, or otherwise it is called as a Seebeck effect. What it means, the Seebeck effect, what it defines means, when two dissimilar metals, here see there are two dissimilar metals, when two dissimilar metals are joined together and kept it in a two different temperatures, one is the cold junction and another one is a hot junction. The hot junction we will have a temperature variation. So, two dissimilar metals are joined together and kept it in a two different temperatures. So, in between these we will feel the electromotive force will be induced. So, that electromotive force is proportional to the rise in temperature. This is the actual principle of our Seebeck effect. So, here it shows there are two junctions, measuring junction, it is otherwise it is called as a hot junction. So, this is a reference junction or it is called as a cold junction. So, these are the two dissimilar metals, we are joining together two dissimilar metals and we are make it as a two junction. One is we are just keeping as a reference, that is a cold junction, another one is a hot junction. So, here only the heat source is given. So, these junction senses that heat source and it produces some electromotive force, that the induced EMF is measured by means of connecting a voltmeter here. So, we will get the corresponding temperature changes, we will get the output voltage. Normally it will be in the range of millivolts. The types of thermocouple, there are so many types are available, they will say nearly 13 types of thermocouples are available. So, in that how it types is classified means by means of the two dissimilar metals used. So, if I use that platinum rhodium, that is the type is called as type B. If I use that chromal constantan, it is called as type E. So, the likewise it is various types. So, it is given as the various types. So, for the particular range of temperature, So if it is a 0 to 1700 degrees Celsius to be measured, we have to select the type B temperature, type B kind of thermocouple. In that type B thermocouple, we will have the positive, both the legs we will have positive and negative, that is the two dissimilar metals. So if I have one leg or one metal is platinum, 30% platinum and rhodium, so another leg is, another lead of wire is platinum 6% and rhodium, then it is called as a type B kind of thermocouple. For example, here it is a type T, means if I want to measure a very low temperature, starts from some negative values, so I can select the type T. So it is nothing but one end of the wire is called as a copper and another one is called as a constant N. So likewise we have to select that thermocouple for the basis of temperature range. What is our requirement to measure the temperature? Based on that I can select the thermocouple. So based on the positive leg and negative leg used, it is classified as type B, E, J, K, N, R, S, T. So this is the color code normally it is used, that is in this international standard color codes it is used. So these are the characteristics of thermocouple. So if we plot a graph between the temperature and the produced output voltage, so these are the characteristics I am getting. S type, S, or it is mentioned as alphabets, it is nothing but the type of thermocouple S, R, C, T, J, K, E. So in that thermocouple, among all the types, I can conclude that if I want to get the linear relationship, linear characteristics, I can select this K type. So in the previous slide, so type K is used for minus 100 to 1300 degrees Celsius. So the normal application we will select, we will go with that type K because of its linear characteristics and the wide range of temperature. So these are the merits of thermocouple. So why I can select thermocouple? It is a wide variety of designs. So I can start from minus 300 to I can extend up to some 3000 degrees Celsius. I can use this thermocouple, and it is a speed of response is very high and it is more suitable for the measurement over a large temperature range. So some limitations, it is having some limitations. So that limitations are, it is a temperature voltage relationship is not fully linear. Some type of thermocouple is a linear, produces the linear characteristics, and most of the type of thermocouple it not give a linear relationship, and it is not suitable for the moving objects. I already told you it is only for the contact type of temperature measurements. If it is, this is also a limitation, it is a contact type. Wherever we want to make it as a non-contact type, that means a very high temperature like molten metal, steel manufacturing, in that case I cannot select the thermocouple. So it is not suited for that. So in that case I have to go with only the non-contact type of thermocouple. So the accuracy part, it is a fair accuracy, not so bad, we can have some better accuracy. So by making some design calculation we will improve the accuracy. So that is one of the limitations of thermocouple. So based on that, what are all the characteristics should be considered before selecting the thermocouples means. So thermocouple must be selected to meet the application and conditions. So the applications mean if I want to use it for a particular process, the process may be the range from, so I have to know the minimum range and maximum range of temperature measurement, then only I can select which type of thermocouple I can select it. So I have to know the applications and process conditions is necessary, then only I can select the thermocouple. The second one is selection consideration. So what are all the basis I can select means, so according to the temperature range, I just told you, select type J, K, M, T or another based on your temperature, necessary temperature. So according to the response time, so all the thermocouple won't give the same, won't have the same response time. So based on the response time, if I want to get the responses more quick, then I can go with some thermocouple. If I want, I can compensate the response time, but I want to have the particular temperature range, so that I can go with the particular thermocouple. So based on the, according to the response time, you can select the thermocouple. If the larger diameter, if you have the larger diameter of these materials, these wire, so it will be the larger diameter reduces the response time. So according to the service life, larger diameter will increase, will have more service time. So based on your requirement and based on the necessity of the process, so you can select the thermocouple accordingly. These are the some selection criteria I have listed. So the another one of the most commonly used temperature measuring sensor is RTD. So we have discussed in the last class. So I am just having the comparison between that thermocouple and RTD. So it is a thermocouple is a self powered, it's simple, rugged and inexpensive. Wide variety is available, wide temperature is available. So these are the main advantages or merits of our thermocouple when compared to our RTD. Any question and answers? Thank you.